In this screencast, we are going to look at how do we draw Lewis structures with single bonds. A single bond is where a pair of electrons, or two electrons, is shared between two different elements. So we can represent this two different ways. A single bond can be represented with a dashed line between the two elements showing where the shared electrons are. Or the other way is by drawing two dots between the elements that are sharing to show that it's sharing two electrons. So let's continue looking at how to do this. So a Lewis structure that shows a single bond will be when a pair of dots between the two symbols represents the shared pair, or that dashed line. So like in our example from before, we had HCl with the line between the H and the Cl, and then we had additional dots around the chlorine. So the single bond is the covalent bond where that one pair of electrons is shared. So that's where this line is drawn here. That's our single bond. In addition, you can see that chlorine has additional electrons around it, and these electrons are not part of the shared bond. And so those are called unshared pairs or lone pairs of electrons. Okay, so those are those electrons that are around the chlorine that are not part of the bonding electrons. So in a Lewis structure, we show the bonded electrons, and we also show the unshared pairs or lone pairs of electrons. So the pair of dots representing the shared pair of electrons, again, is represented often by the long dash. So when we're looking at our example of hydrogen chloride, right, we had a dash between the hydrogen and the chlorine, and then we showed the remaining dots around the chlorine. But we could also, instead of having the dash, have two dots that were representing the shared pair between the chlorine and the hydrogen. So either way is correct, both are fine. In a structural formula, okay, we're going to show the electrons that are being shared, but we do not show the unshared pair of electrons. So for example, F2, if we draw the full Lewis diagram, we know that the two fluorines share a pair of electrons, and then each fluorine then has an additional 6 electrons around it. But in the structural formula, we do not show those unshared pairs. Okay, likewise in the hydrogen and chlorine molecule here, okay, the structural formula does not show those extra electrons that are around the chlorine atom. The structural formula is only showing the electrons that are bonded together between the two atoms. All right, so how do you draw a Lewis structure? Well, I'm going to show you how to using the example of CH3I. So your first step, step number 1, okay, is to determine the type and number of atoms in the molecule. So when we look at the molecule, we see that we have carbon, we have hydrogen, and we have iodine, okay? We also can see from based on the formula that there's 1 carbon, there are 3 hydrogens, and there is 1 iodine, okay? Now, what you need to do next is you need to figure out how many valence electrons each of those elements has. That's step number 2. So if we look at the periodic table, we know that carbon has 4 valence electrons, hydrogen has 1, and iodine has 7. So 1 times 4 is 4, 3 times 1 is 3, 1 times 7 is 7. So when I add them up, I get a total of 14 electrons. So in my Lewis structure, I need to make sure that I have 14 electrons present. Okay, so step 3 is to determine the total number of valence electrons that you need in your Lewis structure. So we already did this on the previous slide, but remember we had the formula CH3I. Okay, so we said that we had 1 carbon times the 4 valence electrons for carbon gave us a total of 4. We had 3 hydrogens times the 1 valence electron that hydrogens have for a total of 3. And we had 1 iodine times the 7 valence electrons iodine has, which gives us a total of 7. And when we add those numbers together, we needed a total of 14 electrons in our Lewis structure. Now remember, when we draw a Lewis structure, our electrons are represented with dots. So that means we need 14 dots on our Lewis diagram, which is going to give us our 14 electrons. Okay, so when we're drawing Lewis structures, typically the first element goes in the center, but it's important to know that hydrogen will never go in the center, and that's because hydrogen only has 2 valence electrons, Okay, and so if it goes in the center, it can't really bond with much else. And our goal with our Lewis structures is to end up with all of our elements following the octet, which means that they're going to have 8 electrons. So we start by writing the first element down. Now, our example was the CH3I, and we've been working with that one here for a little while. So we're going to start by adding our carbon, and then we have 3 hydrogens that come next. And then we have an iodine. Okay, and what we're going to do is add in our electrons. So carbon has 4 valence electrons, and hydrogen has 1. So each hydrogen is going to share a valence electron here with carbon. Iodine is also going to share. So that takes care of carbon's octet, because carbon has 2 electrons here, 2 here, 2 here, and 2 here. So we have 2, 4, 6, and 8 valence electrons. This, however, does not fulfill the octet rule for iodine. So what we need to do next is we need to go back to iodine, and we need to fill in with the unshared electron pairs. So iodine had 7 valence electrons. We're going to fill the rest of those in. And so now iodine is also following the octet because it has 2, 4, 6, 8 electrons. Now, if you recall in our previous discussion that this model was supposed to have a total of 14 electrons. Okay, so we need 14 dots represented here. And if we count, we have 2, 4, 6, 8, 10, 12, and 14. So we know that our structure is correct. Now, if we were going to go back and fill in where we have our shared electrons, if we're going to fill that in with lines, what our model would end up looking like is carbon in the middle, and it's going to be bonded with this one line showing that 2 electrons are being shared to each hydrogen, and then that's the same thing that happens with the iodine. And then we go back in and we fill in our unshared pairs around the iodine, and that still gives us 14 electrons. All right, so let's try another example. We have SiF4, and we want to draw the Lewis structure. So we're going to start by listing what is present in the compound. So silicon and fluorine. I have 1 silicon, and silicon is in column 14, so it has 4 valence electrons. I have 4 fluorines, and if I look at fluorine on the periodic table, it's in column 17, so it has 7 valence electrons. So 4 times 7 is 28. And when I add them together, I get that I need a total of 32 electrons. So I start by drawing silicon in the middle, and it's going to be surrounded by fluorine. All right, so we spent some time talking about single covalent bonds, but there are also multiple covalent bonds. I'm going to talk more specifically about them in a future screencast, but just know that there are double bonds and there are triple bonds, and what's happening is we're increasing the number of electrons that are being shared between 2 atoms. So very similar to single covalent bonds, we're just adding another step. So that will come up in a future screencast.